Okay, today we're going to do 12.5, which is about finding the volume of a 3D shape. So remember that when we're looking at volume, we're talking about how much space is inside of something. So let's just go through some vocabulary really fast. A prism would be a solid that has two congruent parallel polygons called bases. So basically you've got like in this one we have a rectangle on the top and the bottom, and then four rectangles that surround those. The next one is a cylinder, which is it's kind of like a soda can, when you've got two congruent bases that are circles. Whenever we have a prism or a cylinder, they have what's called a height. And to measure the height, you've got to measure the length of the segment that is perpendicular to both bases. So for example, if I were to look at a cylinder and like connect the circles, the centers of the circles on the top and the bottom, that would be the height. A solid with a polygon for a base and triangles for all the other faces is called a pyramid. Pyramids are going to have a point on them. And then the next one is a cone. It's kind of like a pyramid, but now the base is a circle. And again, both pyramids and cones have a height as well. And that's where you basically connect the top or the point of the pyramid straight down, so it's perpendicular to the base. So you can see the height kind of drawn in on both of these. And the next one is a sphere. And I know you guys know what most of these are. A sphere is just all the points that are the same distance away from the center. So if you were to like take the center and go out like 2 inches in every direction, up, down, left, and right, and trace it out, you would get a sphere. And then a hemisphere is just when you chop the sphere in half and you get just half of it. Okay, so our goal now is that we want to be able to find the areas of any of these shapes, the volumes of any of these shapes. In order to find volume, you kind of need to know how to find area. So let's go ahead and go through some of the areas here. To find the area of a rectangle, remember it's length times width. The area of a triangle is 1/2 times the base times the height. And the area of a circle, this one we already reviewed during 12.3, is pi r squared. Remember, area tells you like how many square inches are inside of a shape. We're looking at volume now, so now we're going to make it 3-dimensional. So let's talk about prisms first. If I want to find the volume of a square or a rectangular prism, your volume is going to be the area of the base times the height, which you're often going to see written like this, where the capital B stands for the base. So base times height is kind of your go-to volume formula, and then you just kind of figure out how to find the area of the base. So in this case, since the base is a rectangle, the area of the base is length times width, and then you multiply it by the height. Same thing with the cylinder, you're going to do area of the base times the height. In this case, the base is a circle. The area of a circle is pi r squared, and then you're going to multiply that by the height. So let's go ahead and do some examples here. Let's say I want to find the volume of this prism. In A, it's a rectangular prism. So I need to multiply the length of 14 times the width of 4 times the height of 9. So basically each of those dimensions get multiplied together. If you want credit on your homework, you have to have this formula written out. You have to write out what you're typing into your calculator. 14 times 4 times 9. That gives you 504. Remember that when we're finding volume, you're going to have cubic inches. Kind of like with area, you have square inches. Okay, so the next one. So we're going to multiply the length times the width times the height. So 2 times 11 times 11. We are going to get 242 cubic inches. All right, let's do some cylinders now. So for cylinders, our formula is pi r squared h. So let's just make sure we know where the r and the h are. The r is going to be the radius of your base. In this case, it's 4. And then the h is going to be the length, basically, or the height of your cylinder. So we're going to do pi times the radius squared times h. And again, you need to have that written out on your paper before you type it into your calculator. that is going to give me 552.92. Oops, that is kilometers. Kilometers. Cubic kilometers. Okay, let's do another one. So in D, notice that the height is 6. Here I've given you the diameter. So the diameter is also 6, but I need the radius. Radius would be half the diameter, so the radius is going to equal 3. So my formula is going to be pi times 3 squared times 6. We have a calculator out. Pi times 3 squared times 6. You get 169.65 cubic meters. Okay, so that is all my formulas for prisms and cylinders. Okay, pretty straightforward. Let's look at spheres and hemispheres. So the volume of a sphere is a little bit weird. It is 4/3 pi r cubed. Then if you want to do the volume of a hemisphere, notice that's just half a sphere. So you're just going to multiply that by 2. So it's going to be 1/2 times 4/3 pi r cubed. If you simplify that down, it would just be 2/3 pi r cubed. Okay, and make sure again that you're using the radius here, not the diameter. So in A, we're finding the volume of the sphere that has a radius of 9, so 4/3 times pi times 9 to the 3rd power. Make sure you write that down, and then you can punch it into your calculator. So 4/3 times pi times 9 to the 3rd power, and we get 3,053.63 cubic kilometers. That is a big sphere. Okay, let's do another one. First thing you'll notice in B is that it's given you a diameter length of 18.8. So you're going to need to chop that in half to find the radius length. So your radius is 9.4. And we're going to plug it into our formula. 4/3 times pi times 9.4 cubed. Punch that into your calculator. And you're going to get 3,479.14 cubic yards. Okay. All right, in example C, I'm looking at a hemisphere instead of a sphere. It has a radius of 12. So now instead of having 4/3 pi r cubed, it's going to be 2/3 times pi times the radius cubed. Punch that into my calculator. And I get 3,619.11 cubic meters. Wow, those are all really big examples. I didn't mean to make all of them so big. But that's your spheres and your hemispheres. Let's do our volumes of pyramids. Okay, when you're looking at a pyramid, it's going to feel pretty similar to finding the volume of a prism, where you're going to do the area of the base times the height, but you're going to multiply it by 1/3. So for example, if I'm finding the volume of a pyramid that has a square or a rectangular base, I'm going to do 1/3 times the area of the base, which would be the length times the width, times the height. Same thing with a cone. I'm going to do 1/3 times the area of the base, which is pi r squared, times the height. So let's do some examples. In this cone right here, in this pyramid, let's go ahead and label my dimensions. My base is going to have a length and a width, and then the 12 is the height. So to find the volume of this, it'd be 1/3 times 6 times 11 times 12. You're going to write that down if you want points for it, which you do. Punch it into your calculator, you get 264 cubic feet. Okay. Next one is a cone. So you're going to do 1/3 times the area of the base, so pi r squared, times the height. 1/3 times pi r squared times the height. You get 113 0.1 cubic meters. Okay. All right, take a second really fast. Try to do the next two on your own, so hit pause and then come back and just check your answers. Okay, if you got to D and you plugged 10 in as the height, then you did something wrong. So let's talk about that. So notice that this 10 meters right here isn't the height of the cone. The height of the cone, remember, needs to go straight down to the base right here. So we kind of need to find that angle. Now we don't know that length. What we're going to do is we're going to create kind of like a sideways right triangle. So I'm going to connect these two lines. And I'm going to trace this in my highlighter really fast. We are looking at this right triangle that I'm highlighting in yellow right here. It's kind of sideways, kind of standing up, but we need to find the height, which is that vertical side of the triangle. And we need to use what we know about the triangle to find that. We notice that the hypotenuse of that right triangle is 10, and the base of that triangle is going to be 6 because it goes right to the middle of the base of my pyramid. It's going to be half the length of the other sides. So we've got to solve Pythagorean theorem. 6 squared plus h squared is equal to 10 squared. Okay. So you can take a second and you can evaluate that in your calculator. And you're going to figure out that h is equal to 8. So that's what you're going to plug in for your value here. So just make sure that when you're using these formulas, that you're using the right values. A lot of the actual formulas are pretty easy. You just got to make sure you're using the right numbers for each of the numbers that you plug in. So 384 cubic meters. All right. So those are your formulas for volume. You can go ahead and jump to your homework now. I will make sure that I have an answer key available for you guys as well.